Hey everyone, thanks for listening to another episode of DIB Innovators. Today I'm speaking with Adam Warmoth, founder and CEO of Chariot Defense. Adam, thanks for talking with me today.
Yep. Thanks for having me on, babe.
Yeah, super excited about this one. I just love the companies that we're bringing on the pod, if you will. But you have a really cool background. Why don't you start off with, kind of 2-3 minute origin story, and what connects you from like Stanford engineering, the cool companies you've been with, all the way then to founding Chariot Defense.
Yeah, absolutely. So the great thing about Chariot is it's kind of really a culmination of everything I've done in my past. So as I give my background, I'm also kind of giving you a prelude to why Chariot exists in the world and why I started it. So backgrounds in engineering physics and mechatronics, did those degrees while I was at Stanford playing varsity water polo. So got the student athlete experience, a ton of fun. And while I was there, got plugged into the kind of emerging community of electric aircraft. So ended up in the lab of a guy named DeLon Crow, a professor who had just come back from starting one of the first like Larry Page funded secret eVTOL labs, electric vertical takeoff and landing aircraft labs. So I was doing some drone research back in 2015 while I was on campus, and then turned that into an internship at Kitty Hawk, Larry Page's other flying car company, getting to build actually those aircraft hands-on. After I graduated, I went back to finish my master's, and when Uber was just standing up a division to study how this new type of transportation could impact their business and how they could incorporate it. And so went and joined as one of the first employees at Uber Elevate, getting to work with the entire eVTOL industry to help kind of think about how to bring this product from, a cool idea enabled by cool technology to a business. So really cool learnings while I was at Uber, really on kind of how to think, from a product and business mindset, someone coming from an engineering background. Then got connected to the team at Anduril as they were starting to build out a product function, one of the first product managers to join Anduril. Started on the counter-intrusion program, doing our base defense and border security work, scaled that program up, and then had the opportunity to transition and do counter-UAS work with SOCOM, kind of get into how that informed the idea behind Chariot, but fielding advanced sensors, robots, edge compute into expeditionary environments to provide counter-drone detection, and doing that pre-Ukraine, right? When drones were a topic, right, but not the topic. And so got some really cool exposure to that problem early on. Went back into my roots of eVTOL for a little bit as Archer was starting to think about commercialization and start thinking about defense as well. You might have seen recently in the news, Anduril and Archer actually collaborating on a hybrid electric aircraft. So it was fun to get to bring those organizations together. And then have the idea and inspiration for Chariot, which kind of brings together those two industries. And I'll get into that as we start talking Chariot.
Perfect. So in one sentence, what is Chariot's mission and what battlefield power problem are you trying to fix?
Yeah. So what we were doing is we were building the power layer for robotic warfare. So there is a complete transformation happening in warfare today, driven by this revolution in robotics and sensors and compute. And we were building the infrastructure layer of power behind all of that.
Okay. And so how before you and before this, transformation, if you will,
Yep.
talk to me about how power was used in these, use cases and
Yep.
then how you guys are looking to fix that.
Yeah, so the reason Chariot exists today and not 5 years ago, part of it's on the technology side, and I'll get into that and my exposure to that technology in the eVTOL world. But part of it's the evolving problem set. So if you kind of think about there's a couple different converging factors that are creating these incredible challenges of power that we didn't face before. And basically, if you think about how we were fighting during counterinsurgency, we were spending time on kind of short patrols and then going back to large bases. And so we like to actually say we're a power company, not a battery company, because when people think batteries, they think about the little 2590 radio batteries. Some of them sitting right behind me here, right? The CWBs. You think about, okay, I throw those in my pack, I use them to power my radio, and I take them back to the fob and I charge when I'm back. And in the fob, I've got the large generators, got the massive infrastructure, got the infinite supply chains, not worried about signature management. I'm not worried about mobility. I'm not really that worried about efficiency. I've got kind of enough backups, right? So I don't have to worry about reliability. So basically, you kind of have these kind of barbell extremes of where the operations were happening, right? Big fixed site or short patrol. And the only thing you really needed on that short patrol was a radio. The shift in terms of a kind of modern large-scale combat, near peer, fighting in an anti-access area denial environment is much more reliance on pushing capabilities down echelon, much more reliance on being able to operate self-sufficiently for longer periods than just that 12 or 24-hour patrol. So basically what that's doing, it's pushing capabilities down. It's decreasing the ability to deliver power as you more about signature management, as you worry more about mobility and signature management from a thermal and acoustic perspective, but also from a resupply perspective. And so you're spending time now on, instead of these 12-hour missions, you're spending on a 96-hour mission. You can't bring enough 2590 to last you 96 hours with all the electronic equipment being thrown at you. And we kind of tie this to the story of, kind of thinking about hey, I need to see over the next mountain, right? You think about a platoon out there that needs to see over the next mountain. In the global war and terror era, you'd call back to the base, right? They'd launch a drone from a runway. That drone would come overhead and stream you down, full motion video. Every link in that chain is broken in a large scale combat operation environment. If that callback for support is going to get you triangulated and detected and targeted, that runway back at the FOB, 20 clicks back, has now been blown up and targeted. If that aircraft does get overhead, the enemy has counter-UAS capabilities to take it down, and then that video stream is going to be jammed. And so kind of all those links being broken, which means you're pushing ISR and EW down to the company platoon level where they don't have the power capabilities on their current platforms to sustain it.
And so what gave you this perspective working at Archer, I guess, where this was the problem? Just talking to folks, or was there something like...
Yeah, that was my experience at Anduril really that gave me insight into this problem.
Yeah.
Yep. So, we were, like I said, we were supporting SOCOM for counter-UAS technology for Ukraine. We're fielding all of these advanced sensors, advanced countermeasures, right, robotic systems, edge compute into expeditionary environments. And we constantly ran into power as our limb fac on our operations. And so you have these kind of highly variable demands for power. But what generators are good at is putting that power at kind of one constant level. And to be clear, we support generators. We love generators. We like to say we're the most diesel-loving battery company out there. But it's using generators for what they're good at and then using batteries for what they're good at, by kind of hybridizing these systems. So without that hybridization capability, what we had to do is we had to bring the largest generator to fit that kind of peak power demand and then run that generator at 5% of its rated load 90% of the time when we're in that kind of passive hiding, sensing mode, because we needed that extra capacity to be able to surge when that power is needed. And while batteries are much less energy dense than fuel, they're much more power dense in terms of delivering that big surge of power when you need it. And so we're able to significantly reduce the mobility challenges of towing those large oversized generators around, reduce the reliability challenges of when that generator fails, you have no backup, reduce the signature challenges of having this huge thermal acoustic signature, and reduce the logistical resupply challenges because you're using your fuel much more efficiently when you're running in this hybrid configuration.
For I'm aeronautical engineer, but I haven't practiced in a very long time, if at all. How does this work? What do you get? What is this hybridization? Like, what are you actually doing?
Yeah, so the secret sauce is basically combining some incredible technologies coming out of the commercial sector. And so there's been some innovation happening from companies like Tesla, from companies like Archer, where you've had massive breakthroughs in high voltage lithium ion batteries and advanced wide bandgap power electronics, which allow you to do solid state power electronics and power conversion, in microcontrollers to be able to actually orchestrate all of these microgrids at the edge. So those key technologies have had, Moore's law type, reduction in cost, increase in performance over the past 30 years, but that's all been happening in the commercial sector. And so, coming from my experience at Archer and at Kitty Hawk, and then bringing in teammates, we're based here in South San Francisco. We're able to recruit from companies like Tesla and Lucid and Rivian and Archer and Joby. And we're able to pull in all that high voltage systems talent. And that's really what's enabled, this kind of hybridization, where getting up to those high power levels, high voltages, you really need to embrace this new technology, which is almost a completely different paradigm relative to kind of traditional low voltage batteries.
Okay, so what's your core product then?
Yeah, so we've got one of them sitting right behind me right here. This is our M424 product. So this is a system that basically drops into any tactical vehicle, pulls in different sources of power, DC power from the truck itself, AC power from generators, solar power, pulls all those in simultaneously, and then provides high burst surge AC and DC power out for charging drones, for powering electronic warfare, for providing uninterrupted power to C2 systems. So the fact that we've kind of decoupled the inputs and the outputs means if your input fails or as you're transitioning different inputs, your output stays uninterrupted. It also allows to provide much higher surge power than what any of those single sources can provide. So that right there is M424, again, integrated energy storage, power distribution, power conversion, power management. And then we also have our M4R400 system, which is a larger 30 kilowatt system that actually pairs with existing generators and effectively hybridizes them. So turning a 30 kilowatt generator into a 60 kilowatt hybrid system.
So that one's not mobile. That's more like at a FOB, you would use it, for example.
So it's actually built to integrate directly into the Army's generator trailer. So all of the trailers they currently use to move their 15, 30K, 60K generators around, we just slot our system right under that generator. So kind of maintaining the same mobility. It is more of a brigade division level asset, whereas this one's going to be your battalion down to your squad. But yeah, so a little bit less mobile, but a lot more power.
And so before you, how would they do anything? How would they carry batteries? Just a lot of those other batteries?
Yep, exactly. And so, and that's where in that previous paradigm, you ask any soldier, how they feel about these things. And, they're used to having to throw 6 of them in their ruck and carry them around. But yeah, with the increase in the fielding of drones, with the increase in pushing things like EW and counter-UAS down to the lower echelon, they can't bring enough of those forward. And so what we're seeing in a lot of these exercises is that just means that new equipment just doesn't get used. You got a bunch of expensive, cool paperweights that you can't keep in the fight. Because your alternative is bring that big generator, and from a mobility perspective, that's a limiting factor.
At least those are pretty light, right? In a ruck.
Yeah, exactly.
So you guys talk about, resilient, low signature, high voltage. Is that a tough thing? Yeah. Are you able to get that value to the customer's base well? And what does that look like taking that, as you develop that to the customers? How are they receiving that?
Yeah, it's a great question. So, we have something we call the powered brainworm, which is when people first hear like, oh, you guys are a battery company, right? Kind of get written off like, okay, we've had batteries. What's new, right? And then as we start to explain how this actually fits into their tactics and procedures, how this makes them leaner and lighter and more distributed, more lethal, more survivable, we bring these out to exercises, and we're not allowed to take them home. We've sold unit systems directly to these units. Even some of our very early prototypes who said, you're not leaving with that. Now that I know this exists, I can't live without it. So when we're able to get into these exercises, that's really where we're seeing a ton of value. And the Army Transformation Initiative that's being led by Secretary Driscoll and the Chief of Staff of the Army, General George, has been a game changer for us, because when you're doing a parking lot demo of all these new drones, you don't really need our stuff. You go back and charge at the hotel at night, you bring it back out, you kind of do the demo, and everyone claps, you go home with a bunch of dead batteries. When you're out on day 7, day 10, day 14 of a real operational force-on-force exercise, that's where our capability shines. And so the transformation and contact exercises these brigades are doing at these training centers really allows us to get our equipment out there alongside all this other new electronic equipment, and really show kind of the benefit of where our technology fits in. So yeah, so once we're able to kind of talk tactics, talk about employment, get this into their hands and get it into an exercise, we've seen incredible demand for the product.
It's great. So when you've got, you go forward deploy, it's contested, denied, lots of sensors out there trying to find anything they can to target the threat. How does your signal management compare to, other batteries and, what you're doing? And how do you measure or minimize that, all those signals, if you will?
Yeah, it's a great question. So, the biggest ones that we think about where we have the most immediate impact relative to generator, right, is the obvious ones of thermal and acoustic. And so this thing is silent in operation. The thermal signature is significantly lower than a generator. And what we're saying is, right, we're not necessarily replacing generators, or we're not necessarily replacing trucks. We're forward where they don't have generators, we're just charging right off the trucks themselves. But that engine, right, that exhaust from an engine, that exhaust from generators, lights up like a Christmas tree on infrared. And we're now operating against an enemy that has proliferated, infrared sensors. And so it's that ability to cut that infrared signature during critical windows and choose when and where you're emitting, right? Again, we're not saying leave all your fuel at home, leave all your generators at home, but it lets you kind of decouple and choose when and where you have that signature. And then when you're running just off the battery, it's nearly zero thermal signature, nearly zero acoustic signature. Part of the reason why it's such low thermal signature is because of how efficient the electronics are getting, coming from all of that great technology from the EV and eVTOL industries. Every percentage point of efficiency is less heat that you're wasting and emitting out into the environment. So significant thermal and acoustic signature reduction, which helps with kind of immediate detection. And then talked about that logistical signature, right, of the trail of ants, right, coming back and forth to your position to resupply. You're significantly reducing that resupply rate and helping reduce signature that way as well.
That makes sense. And so just to give, if there's a way to measure that. So we have a drone that you want to, charge out there. Compared to charging, let's say on a truck or charging with those other batteries, what's the difference to, kind of power throughput,
Yep.
the surge, how many can you do? Like if you were to try to quantify that in someone that's not measuring, kilowatts per hour.
Yeah. So, I mean, part of the reason why, at these early exercises, they had so much challenge fielding these drones is they're not thinking in kilowatt hours. The logistician spreadsheet doesn't have a line for kilowatt hours. But so the way we think about it is, and what we've demonstrated a couple of different exercises, is we're basically 3xing to 5xing the sortie rate on UASs. And so that's because of the ability to provide that rapid surge recharge capability. So even though we're pulling power from the truck, we can surge 4 to 5 times higher charge rate than what they
Wow.
can pull off the truck itself. And so that lets you get that drone charged and back in the air faster. The other thing is the ability to do AC or DC output. So the fact that we can do direct DC charging, just like with an electric vehicle, when you want to charge that vehicle fast, you go to a supercharger, and that's giving you your high voltage DC much faster than your level 1 charger at home. The same limiting factors there on why your level 1 charger at home is so slow, because of the voltage and the kind of that 120 single phase wall outlet power and just the max power you can push over a 15 amp circuit. So we can do that fast DC charging as well. And we've actually got a port on there that's kind of dedicated directly for commercial kind of drone charging standards. So a combination of the fact we can provide that rapid DC charging, and we just have a much higher capacity than the sources they have available to do that surge power. Yeah, we've seen it at 3 to 5x the sortie rate that these units are able to achieve in the field.
And is that your primary use case that you're selling right now? Is, just mostly the drone, forward, battalion level or company level, out on the field, drones and other unmanned platform charging? Is that really the prime target?
Yeah, it's a great question. Drones are the hot topic, right? Everyone's talking about drones, and it's certainly a big, feature of our system, right? Is that increased sortie rate, specifically for drones. There's other systems though that have significant benefits as well, that we're seeing more and more demand from. One of them is like the next generation command and control systems that are continuously requiring more and more power to do that at compute. You hear all over the news, right? All the problems we're having powering our data centers domestically when we actually have a grid to plug into. Now you think about all that sensor processing happening at the edge where there is no grid to plug into. And that uptime, that reliability, that 4 nines, 5 nines of uptime is really critical, for your communication systems, your compute systems. So that uninterrupted power is really where you see some value and where we're getting a lot of traction in the C2 community. And then on counter-UAS as well. So things like electronic warfare, directed energy, things where you actually, it's kind of that perfect thing where you have a really low draw and you're really sensitive on your signature. You want to be passive and hiding and sensing, but then you want to have a big surge of power when you decide to go active. So things like electronic warfare, counter-UAS, we're seeing significant demand there as well for both the uptime and the reliability, as well as that ability to provide that high surge of power in a compact form factor, but also keep the systems online without signature when you do decide to go into MCON.
In this hybrid model, is there more of, I would say, a reduction in, you hear about batteries a lot of times, and some have gotten better, but even just the more you charge it, it sounds like this is charge, expend, charge, expend. Does that affect battery life, if you will?
Yeah, so just like any battery, it'll have the same thing, just like your iPhone, right? Well, we've designed our system intentionally to be very modular in terms of replacing that battery over time. So, you're looking at years, right, of operation, 5 to 10 years of operation before you start to see, significant degradation based on the kind of increased improvements in the battery chemistries. The great thing is though, when that happens in 5 years and you decide you want to swap this out, one, your system doesn't break, it just starts to degrade. And two, it's designed as a unit level maintenance task. And so we have this as batteries that we're using standard military batteries in these systems. So we're not really innovating on the battery cell chemistry or anything like that. Our innovation is in the power electronics and the power control. So we're using common kind of standard batteries that in 5 years, when you decide you need to go replace that, great, you're getting the next kind of 5 years worth of battery cell innovation. And actually that drops in better than when you bought it. And so it is certainly a thing like any battery system, but as you said, it's we're coming out with better and better cycle life in our new chemistries. And when that replacement does happen, it's an end user level maintenance task, and they're getting a better system when they started.
Makes sense. And so you guys did this pretty quick, right? The concept to field and how long?
Yeah. So first check to first field exercise was 3 months. That was the Naval Postgraduate School JFIX event at Camp Roberts. And then first check to real force on force exercise was 6 months. So we were air assaulting equipment in with 101st Airborne at GRTC 6 months after that first check into the company.
So let's back this up. So did you start the company before the first check? Like, I mean, how long were you around and how much development?
Yeah. So the company was me in a spreadsheet, me in a PowerPoint deck starting in August of last year. We raised and received our seed funds in November. And then we were in May at GRTC.
I got to tell you, that's pretty damn impressive. There are a lot of companies that barely have gotten their pitch deck ready in a year, never mind roll out to be fielded. That's amazing.
Thank you.
What are the biggest lessons learned in that process for you?
Yeah, so part of why we've been able to move fast is really leaning on the lessons and the technology coming from my background, and kind of why I was like, hey, my background actually really is the story of Chariot. So from a technology side, the reason we've been able to move so fast is we are leveraging mature commercial supply chains from the automotive and electric aircraft industries. And then on the go-to-market side, really leveraging the learning from Anduril. Got to learn from the best in the world there on running defense go-to-market, running programs, running capture strategies. And so, super grateful for my time there. Can't imagine doing what I'm doing without that experience. But yeah, just taught about kind of how you have to manage this octopus, eight-legged stool, whatever you want to call it, of, it's not just the end users that matter. It's not just the program officer that matters. It's the labs, it's Congress, right? It's the GOs, it's senior leaders. And so you kind of have to manage all of these stakeholders and kind of run a campaign that and have a kind of cohesive theory of victory. I kind of find that's missing sometimes in some of these early defense tech pitches is, okay, it's a cool technology. How does this actually become a program of record, right? Who do you need to influence along the way to get there? And so, yeah, really been able to leverage that learning. And again, I think there's no way we'd be moving as fast as we would be without the changes happening in the department from an acquisition reform perspective and from the Army Transformation Initiative perspective. And I think we're seeing that from the senior levels all the way down, where brigade commanders at these trainings are no longer being evaluated on how they performed against the OPFOR only. They're also being evaluated on how did you embrace new technology? How did you incorporate new commercial technology into your formation? How are you modernizing?
I did not realize that. So they're getting graded on how well they incorporate innovation.
Absolutely. Yeah. And that's really kind of been that critical unlock that we see is that's senior leader all the way on down to the brigade commanders, to the battalion commanders, right? Down to the junior soldiers who are being, celebrated for their innovation. We've been working with a chief warrant officer, first Cav, who came up with this whole new kind of concept for kind of a passive sensing counter-UAS on the move and just pushed forward with it. And is, now meeting bi-weekly with the chief of staff of the Army, giving him updates on this. So really enabling those junior soldiers, all the way up to evaluating the brigade commanders on bringing that new technology in. So we're really seeing that transformation across the Army, across all levels.
That's really cool. But these are one-offs. So talk to me about, the challenge, the valley of death. You've got people in the field interested, but the real, moneymaker is program of record, right? That's what you're going for. Talking about how's that journey look? What have you seen change? You've spent the time at Anduril and others. How are these other ones? How's it going?
Yeah. So the early traction's been great. We've been able to actually leverage some unit contract vehicles for one-off sales to units, using some couch cushion change. But to your point, right, that doesn't make a venture backable startup. And so that's really kind of the key question that we're looking to answer over this next year is that access, right? That front door has, never been more open in terms of the ability to get in these exercises, get your equipment in front of soldiers, and have just a culture of accepting risk and accepting failure, right? Where, if your system doesn't work and you come in saying it's a TRL6 system and it performs at a TRL6 level, which means it's got some warts, you're not getting blackballed, right? That's understood as a process of development. But yeah, that next kind of level is transitioning into program of record, right? You've seen some of the news around the PAE reform, the acquisition reform, especially in power, we've kind of had some challenges where it's kind of been this kind of no man's land for who really owns the problem, right? It's in the sustainment community for acquisitions, right, and for requirements, but the maneuver force is the one fielding it. And so it's kind of this you got this kind of mixed bag of kind of trying to align a kind of cohesive around doctrine, around requirements, around an acquisition strategy, and then a fielding strategy that's split across a bunch of departments. And so what we're hopeful is that through the kind of PAE realignment, you start to see in the T2Com realignment, you start to see a little more cohesive structure. And we're hoping to see the PAEs and the T2Com, seated work closely together to make sure that the requirements are kind of being driven not by the way we did things before, but kind of with this portfolio approach. You're seeing some centralization and consolidation of budget line items, allowing the services to move faster. We think that's a really critical component here if we're going to get through the valley of death. It's, we've been around for, to your point, a year, right? Just over. And the budgeting process is a 5-year process. So JSIDS is dead now, long live JSIDS. But, we think that that realignment around funding, around giving the services flexibility, maintaining congressional oversight, but giving the service flexibility in year to reprogram and realign dollars based on some of these emerging technologies, right? If we had to get in line and say, okay, cool, this is great technology, we're not going to make it 5 years. If we don't get a contract in 5 years, right, we won't be around to play the game. So that's really, I think, going to be the big question mark is can this early transformation, right, kind of in the services, can that align with Congress where Congress can maintain that oversight that they need over the spending, but give the services flexibility they need to to adapt in the way that they want to.
Yeah, that's challenging, especially when you have something that's ready to field. So have you gone to the current conflicts and tried to participate or get, offer your capabilities to like Ukraine? I would imagine very interesting and useful technology for those warfighters.
Yeah, we had a lot of conversations there. One of our investors, D3, is a Ukrainian firm and is very plugged in there. We've done some testing in Eastern Europe through a couple exercises. So yeah, we're certainly learning a lot from the ongoing conflicts. The access to the CTC rotations is making it so that we can do that learning here as well. Force on force is kind of the closest you're going to get. Previously, that door was closed, right? If you were some new startup, you weren't getting in, right? And so that access has been great, and it's meant we've been able to do more development kind of in faster cycles, a little closer to home. But we have been spending time understanding those conflicts, doing some testing over there. And so yeah, certainly kind of taking the lessons learned from that, from the experience I had from Anduril, but making sure we're working kind of across different formations, working in different theaters. So we've been up in Alaska, we've been out at 25th ID as well in Hawaii, working with mountain units, right, airborne units, armored units, making sure that the product we're building doesn't overfit, right? Kind of the risk that people are talking about with Ukraine is overfitting technology development to what's happening over there, which may not be relevant to a future conflict that the U.S. would be participating in. So try to take the lessons, but make sure we're not overfitting to those lessons. Make sure we're getting a kind of diverse set of experience across different units.
How about like, let's say agencies, federal agencies or government agencies,
Yep.
look at Skydio and their ability to put drones out on top of buildings and they just sit there and then when they need, they go.
Yep.
Have you been working with organizations like that?
Yeah, so basically anyone that needs off-grid power, right? Anyone who's operating, in austere environments, we think is a market for us. And so certainly kind of over the next year, as we kind of establish ourselves with the Army and with the Marine Corps, going expanding beyond that to DHS, right, to FEMA, to public safety, law enforcement, partner nation capacity building with microgrids and developing nations, So yeah, certainly kind of thinking across the broader spectrum of the U.S. government and of allies as well. So our technology is non-ITAR, which allows us to do more direct commercial sale to our allies and our partners who have these same challenges that we're having with these new drones and EW systems and counter-UAS systems that are being fielded.
Very cool. So if you look at roadmap, where are you guys going? And then where is, I'd say power conversion, storage, where is that roadmap going on a global level?
Yep. So we're focused this year on scaling up production of our current two product lines. We've kind of validated those out in the field at these exercises. We just opened a new facility next to our main headquarters here, which is a dedicated production line, and we're entering low rate production on our first product line. And then also really investing in our software platform, Chariot OS, which is basically that kind of microgrid control component of what we do. And so all of these systems have software running on board that do what we kind of take for granted that the grid does. So all the things we take for granted that the grid does around matching supply and demand, forecasting, prioritization through pricing, load shedding, turning on and off peaker plants, none of that happens at the edge. So someone will go turn on a coffee pot, it'll overload the generator, and it'll take down the air defense radar. And so what we're developing is kind of that microgrid control layer, and then talking about how logisticians don't think in kilowatt hours, also developing planning tools for integration and kind of thinking about how do you plan a mission, thinking about kilowatt hours, thinking about energy as a first class concern, given the fielding of all this new electronic equipment. So those are really our two big focuses: scaling up production and continue to build out our software control platform and planning platform. Where we see power going in general, if you look at there's basically, if you look across the Army, the Marine Corps, Navy, Air Force, and then you look at our NATO and non-NATO allies, there's 1 million ground vehicles across that fleet. The energy storage on those 1 million vehicles today, on 99+% of those vehicles, is between 2 and 6 lead acid batteries that really exist just to start the truck, like just to start the engine. And so we see a massive opportunity to transform all of our platforms to take advantage of this integrated energy storage and power management. As you think about these platforms, not just as moving people around, but moving sensors and countermeasures and other robots around the battlefield, all of stuff that consumes power. And so, we like to say, you wouldn't send a person into battle without, food and water and nicotine. You wouldn't send a robot into battle without comms and compute and power. So our tagline is, we're the robots in.
I love it, nicotine, but oh, how true, how true. Caffeine's harder to consume, so nicotine's easier to carry and consume on that. And so just swimming back to the battery. So this is commercial off the shelf kind of technology. Where's your secret sauce? Like, what are you doing that's different? And do you have any competitors out there?
Yeah, so our real secret sauce is really as we pull in a lot of the technology coming out of companies like Tesla and Apple and Archer and Joby, right? So one of the key breakthroughs there is these wide bandgap power electronics. Silicon carbide is one of the kind of main new engineering materials. So for example, in the commercial sector, Tesla from 2012 with the Model S to 2018 with the Model 3, they were able to cut the size of their drive inverter that takes the battery high voltage DC power and converts that into three-phase power to drive the motor. They're able to cut that component by a size and weight factor of 10. And so that was just in 2018 that really started rolling out commercially. I mean, as you get up to these higher power levels, just the physics of power mean you have to go high voltage if you want to keep current limited and you want to keep your thermal management limited, and just your overall system size and weight limited. So kind of embracing these new high voltage systems, especially on the power electronics, the power conversion, the galvanic isolation. And you see this on the grid as well with kind of the big transformer shortage we're having, right? Limiting our grid expansion. And then there's other companies that are now leveraging these new materials and technologies to develop solid state transformers. A lot of the same breakthroughs happening in the EV sector, eVTOL sector, utility sector. We're leveraging those same breakthroughs in material science and in technology, the core kind of power technology. So that's really where we're leaning in, is on the power electronics, the power conversion, the power management, and then the edge compute and the software and the control that layers on top of all that.
Okay, and so what's going to be your biggest challenge in scaling production?
Yeah, so the great thing is we are leveraging a lot of commercial technology here. Today there is no certified, fully certified by the Navy, and the Navy actually turns out to be the clearinghouse for all high voltage, or actually all batteries for DoD, because if these are going to go in a gray hole, that's the biggest risk factor that needs to be controlled for. So as we start to work with the Navy and the labs there to get some of these high voltage components through testing and through certification, without overly constraining and locking us into kind of legacy designs, right? So the speed at which they can kind of upgrade and certify new technologies is really going to be a limiting factor on the industry as a whole, in terms of fielding of these new high power, high voltage technologies. So that's a potential bottleneck. We're working really closely with the Navy on that. They're making a lot of good strides to try to break that bottleneck and move faster. And you're starting to see some early results from that. But that's going to be a bottleneck on this entire transformation happening across the department, independent of any specific Chariot product.
Okay, so from this production capability, there's aren't really challenges. Like, you don't have a critical mineral material issue. Like, everything is, you could scale, how fast could you scale to build, 100 of those a month?
Yeah. So the great thing about what we're doing with leveraging the supply chain from automotive is and aerospace is automotive solved a lot of those scale problems, right? We're tiny, right, compared to Tesla, right? Ford, GM, right, in terms of the number of vehicles they're putting out every year. And so we're able to kind of tap into that existing supply chain without kind of having critical risks. We're also able to source from US and kind of allied suppliers, because we're operating at a higher price point, right? Because we're selling exclusively right now to kind of federal level agencies. They have that concern around supply chain and making sure we're sourcing out components from the right places. The challenge is not that those components just like don't exist. It's that they're lower scale right now, right? They're not at that kind of same scale, but we're actually able to serve as a customer and in a kind of demand outlet to allow companies who are trying to do reshoring of these critical technologies around critical minerals, refining battery packs, new battery cells, and provide actually an end customer who can buy that and then sell it to the end user, right? The Department of Defense doesn't want to buy lithium, right? They want to buy capabilities and products, and we can actually help be that early demand signal, right? Help able and willing to pay those higher prices to help them get down their cost curve, and we can kind of grow along with them.
Yeah, that's great. What a great model for that. How much capital have you raised? How many rounds, if you don't mind sharing?
So we announced our seed round, which we raised last fall. We just announced it this past summer when we came out of Stealth Reindustrialized conference in Detroit. So that's our announced funding to date is an $8 million seed. And that's what we've used to build out the initial team here in San Bruno, California, and to do this initial prototype development.
How was launching that at that event? Did you get like a lot of like, oh, shit, or
Yeah, it was a lot of fun. I'd been to the first reindustrialized. I'm a big fan of Austin and Ben and the team that puts that event on and the whole kind of New Industrials Alliance. So yeah, it was a great place. From kind of day one, I kind of had that marked on the calendar as a great event in terms of bringing together a lot of like-minded people thinking about these critical problems in defense and energy. And so we had a lot of fun there.
Yeah. So, sorry, just circling back. Are there competitors doing the same thing you're doing? Like, are you finding more people see what you did now that fast followers and
Yeah, yeah.
same capability?
Yeah, so it comes back to the same problem on the government side around kind of this mixed proponency of it's no one's problem and then it's everyone's problem. And so I think the fact that the kind of power thing has kind of flown under the radar, gave us an opportunity to kind of get our name out there and kind of grab the niche. So we're certainly not the first company to think about power, right? In DoD, we're certainly not the first company to do batteries. But in terms of the kind of this integrated and really thinking about platform hybridization and really kind of building for the military first, and then thinking about other markets after that, and really thinking about kind of the other thing we kind of think differently is we think about batteries as power, not batteries as energy, right? We talked about we're the diesel loving battery company, right? Diesel is great energy source, but the batteries really are unique as a power, and trying to make that system actually as small as possible and make the battery as small as possible, but still being able to deliver the power you need. That's kind of been a differentiation for us. So I think in that, and then in the layer on the microgrid control. And so there's people doing kind of components here, but I think, in terms of the full picture, the low voltage, the smaller system up to the higher system, having those be kind of on the same architecture and same core platform is kind of where I think we're kind of a one of one in terms of that complete picture.
Yeah, fantastic. All right, we're gonna start wrapping this up. I'm gonna do what you've probably seen out of the podcast, lightning round, but 5 questions, 1-ish minutes. You can go over if you've got great comments, and I won't comment. I may comment if it's something really cool, but other than that, we'll just go knock them out. Doesn't need to be fast. Make it opinionated and raw. So
let's do it.
What's the biggest myth or misconception about selling to the DoD? Now DOW.
Yeah, I think, you see a lot of people, you get an end user to say, yeah, I want this. You get a retired GO to say, yep, I totally would have bought this. And you think you're gravy, and you're far from it. Those are necessary conditions, but certainly far from sufficient.
Perfect. What's the hardest lesson you've learned, even though you haven't been doing it super long, in building a defense company? Because it's gone pretty well.
Yeah. I think, and I can tie back to my experience in Anduril as well. I think the biggest shift, especially for kind of Silicon Valley companies, is you really have to be honest about the limitations of your product. There's very much a Silicon Valley kind of fake it till you make it kind of ethos. And I think in defense, you actually just have to be really honest about the limitations of your product. The people you're selling to for a career, for their job is managing and accepting risk. And so you have to be very clear about what that risk is with your product, what it can, but especially what it can't do. So that's definitely one of the biggest lessons kind of from coming from Uber and kind of the Silicon Valley into the defense world.
Copy. What's the number one piece of advice you'd give someone starting a defense tech company today?
Let's see. I think, number one piece of advice would be, go work at Anduril or Palantir for a couple of years.
Experience matters.
Yeah, learn the game from the best. You can't really learn how to shape a capture strategy, right, from a book. How to run a GR campaign, just the ConOps and the TTPs, just like how to speak the language. Even knowing to say ConOps and TTPs, right? Which I certainly didn't know what those things were before I started in my time at Anduril. So yeah, that's my kind of hot take version, is just go work there, learn from the best, and then go.
I think it's great. What trend in defense tech are you betting on that others are missing?
I think it's basically the importance of the electron, right? It's the dominance of the electron. I think when you think about, if you look at like predicting the outcome of a soccer game, you can look at time of possession, and that'll 95% of the time predict the outcome. There's some of these critical variables that you can just look at that and it's incredibly predictive. I think kind of dominance over power is going to be one of those things in a future conflict. So that's maybe one of the things we believe that's a little bit different.
Great. And last one, what do you think is the biggest opportunity in defense right now?
Besides power,
I'd be power.
yeah. I mean, I think there's just this infrastructure layer that all of the future systems are going to require. I think we're maybe actually, hey, we're going to go buy 1 million drones. Well, what that's going to mean is now we're locked into that generation of drone because we have a bunch of them sitting on a shelf that now need to be sustained. And we're not going to be employing them at a rate, right, that if we're not in active conflict. So I think there should be kind of more of a focus on building this infrastructure layer. We're obviously doing part of that with power, but comms and compute are kind of equally important parts of that infrastructure layer. So kind of robust, resilient comms, deployable edge compute. That's kind of system agnostic would be another opportunity.
Yeah, it's interesting. Good, nice job answering those. Sometimes it's the non-sexy stuff, right? It's the stuff that makes everything go around. You're going to have people chasing the leading edge, brand new technical or technology to bring to the warrior battlefield, and that's great. But it's these, just you have to have energy, right, to do something. things like that. You have to have strong material that's light, just figuring out kind of the core non-super sexy from like, ooh, it's not going to show up on TV, running around. So I think that's a great point. Well, this has been super fun, Adam. Thank you for your time. Before we go, can you show me what's in the box? Can you pull the box over, or is that no?
I can show you the outside of it. So yeah, you've got your NATO ports on the side here, so we can plug right into the vehicles. So we've charged this off everything from an ISB to an Abrams. You've got your AC and DC outputs. You got one switch operation. So that's a big kind of differentiator for us, as this is meant to be dropped in, and any soldier, any E3, just plug and play. It just works. So we have a lot of complexity buried inside there in terms of the electronics and the controls. But as far as the soldier's concerned,
are you sure all soldiers know how to do that?
we've done it. I mean, you can see the dirt all over this one, right? This was
coming from an airman, so that's a little jab.
Yeah, no, it's been great working, like I said, we've gotten kind of great traction from the E3s up to the 06s up to the generals, and
I guarantee 06s and generals in the Army aren't touching that button because they don't do anything.
They like that their guys have it because it means their drones are in the air.
Right. Hey, super fun. Unfortunately, we do have to wrap this up. But if people want to follow your work, how it's integrating, get in touch with you about opportunities, how best would they do that?
Yeah. So check us out. contact@chariotdefense.com is our kind of broad email. Connect with me on LinkedIn, send a message, follow the company on LinkedIn. We post a lot of updates there. And and we'd love to get in touch with anyone who's looking to come on board. We're gonna be hiring a bunch this year across operations, electrical engineering, mechanical engineering, software engineering. So yeah, please get in touch.
Well, it's been super fun. Thank you so much. Learned a lot, and we'll see you around the block.
All right. Thank you, Dave. This was fun.